Okay, my friends, so this is a continuation of topic 12, and this is the line integral of vector fields that we're getting directly. So we're going to be given this information right here. So first we're given the vector field, which is going to be in this form right here, and then we're given a curve, which again is r just equal to r of t, and then r bounds, right? And then I have here written two formulas, which are in fact interchangeable. They mean exactly the same thing. And I wrote the side notes here that you could definitely write on your formula sheet. But for the most part, we're going to be using this equation right here. And we want to simplify it further. I simplify it further so that it's easier to substitute everything in, right? Okay, so we're going to work out this example right here. You calculate the line integral given number 1, number 2, and our bounds, right? So I used to be very intimidated when I seen these I's and J hats, right? But really, they're just there because we're doing dot product, right? We're doing dot product. We don't really need to worry about that. Professor's not very strict about that anyway. But when you do encounter a problem like this, because I know that we have, I think it was the first exam, kind of panicked, but no need to fret because I'm going to explain to you what that means now. So we're going to solve this, right? We're going to use this equation right here that I've simplified, okay? And we want to find this one first, just so it's out of the way, right? We got r of t given to us as this, but we want the vector form of that, right? Why do we want the vector form of that? Because we're going to be substituting these, right? These is going to be x and y, and we want to substitute these values into here, into x and y over there, right? So that's the purpose of turning this into a vector, okay? And when we do turn it into vector, when you're turning it into a vector, you literally just leave these behind, the i's and the j's, and you take these coefficients of that and you turn it into vector. And then you take the derivative of that because that's what we want for here, and then you get this, right? However, because we are taking the dot product and it is in a form where I and j are relevant, we turn it back to I and j right here, so that we could plug this back into here, because this portion right here is this portion right here, right? And we could take the dot product. Like I said, not 100% relevant when it comes to our class, but pretty useful information. Okay, so we wanted to write our integral from -2 to 2, and like I said, this portion right here is this, but instead of x and y, we substitute these values, so this x, this y, into here, and dot, right, dot product, and we're going to put this into here, like I said, dt. So now we want to get rid of our i's and the j's, right? And we do that by just taking the dot product as normal, right? And like I said, these are placeholders, so you know exactly, it's just makes it very clear what you're looking at. You're taking the dot product, you're multiplying those, and the products you just add together, and then you get this. Now when you're taking the dot product, like I said, you drop these, so you don't need those anymore. What you're left with is this, and then you simplify, and then you just solve as normal, and then your answer is 0. So I hope that was clear, and if it's not, then I'm always here for questions that I can answer, hopefully. Okay.